Okay, so this is the problem from the class that we were discussing, and I promise I would explain this to you later. So I'm trying to solve it here. So what we have is an infinite long line of charge, and let's draw that here. This is the line of charge, and the line is coming out of the screen. That line is perpendicular to the screen that you're seeing, and then you have a proton. The proton starts from some distance Ri, and that is 19 centimeters, and it's going to travel all the way towards the line and end up at some distance Rf. Okay, so the question is, what is this Rf? Rf, that is the question. That is a question that we have to answer. So what do we know? We know the initial velocity. We know the initial velocity, that is 1700 meters per second. And we know the initial Ri, which is 19 centimeters. We need to find Rf. So what we know is this. We have an initial kinetic energy here, and then we're going to have a kinetic energy here, final, which is zero. And that is zero because the electron is going to stop right there. And then there is a potential here due to the field from the line, and there is a final potential here. So the idea is to use conservation of energy. So we know that the initial kinetic energy plus the initial potential energy, where E is the proton charge and Vi is the potential at point I, that is equal to the final kinetic energy plus the final potential energy. And so this is zero, so I can write this as Ki is equal to E Vf minus Vi. So what we need to do is find what this quantity is. And this is the work done by the electric field. This is the work that the electric field due to the line does when the proton moves from the initial distance, when the proton moves from here all the way here. So let's see what happens there. So let's try that. So now the field due to the line is equal to lambda over 2 pi epsilon 0 r. And we studied this in the previous class. So if a proton move from here to here a distance dr, the amount of work that is done is equal to the field at that point times dr, which is equal to lambda over 2 pi epsilon naught r times dr. So the total work done, this W, then is equal to the integral from my initial position to my final position of what? Of the field, the amount of work, right? That is lambda over 2 pi epsilon naught r times dr. And what is this? This is equal to lambda over 2 pi epsilon naught. All this comes out of the integral, and I get r from Ri to Rf of what? 1 over r dr. And then I can now solve this, and this is equal to lambda over 2 pi epsilon naught, and then this is ln of r between Ri and Rf, which is equal to lambda over 2 pi epsilon naught ln of Rf divided by Ri. So this is the work done by the electric field on the proton. Is equal to lambda over 2 pi epsilon naught ln of Rf over Ri. In other words, this is the change in potential energy. Change in potential energy. So therefore, these have to be equal to the kinetic energy. The kinetic energy is 1 half n Vi squared, that is Ki, and that is equal to what? Oh, to E times W. So therefore, I get that 1 half n, and I forgot an E here. Vi squared is equal to E times lambda 2 pi epsilon naught ln of Rf over Ri. And this is basically it. So this expression gives you the solution because now we know everything in this equation we know with the section of this Rf, which is what we want. So we can start simplifying some things. These two cancel, and I get that Rf over Ri ln, that is equal to what? Is equal to E lambda down here, and up here I get that this is mvi squared pi epsilon naught. So now I can take exponentials on both sides, and I get that E, the exponential of the logarithm of Rf over Ri, that is equal to the exponential of all this, which is mvi squared pi epsilon naught divided by E lambda. And now what I get from here is that Rf is equal to Ri times E mvi squared pi epsilon naught divided by E lambda. And when you put your numbers in there, when you put your numbers, you're going to find that Rf is equal to 0.158 meters or 15.8 meters. So basically, if we go back to this picture, this distance here, this distance is from 19 to 15.8 is 4.2 centimeters. Okay, that is this problem for now, and I'll see you back with another problem.